Greetings, Earthlings. How are we? I'm here to have a very quick chat to you today about why statically compiling or statically linking and using Scratch is really important, or killer Cruft. We all know that, so first, just a little bit about me. Everyone calls me SVK, it's easier. I sort of have the privilege of running a few meetups. If you've heard of Beer Ops, I'm one of the guys that is behind that. Come along in December, it's awesome fun. I'm super passionate about open source, not just software, but data as well. I love open data and open government data. Down the bottom, that's some of the stuff that I'm interested in at the moment. The two on the right are really interesting, and I'm going to chat about the ANSI-C today. Yes, I'm going to containerize an ANSI-C application in front of you. The one on the far right, that's Aspen Mesh. That's sort of an incubator for the company that I work with, right? They sponsor Aspen Mesh. They're part of us. Let's talk about statically compiling your applications. Everyone knows you've got an application. The differences are static compilation or static linking. Your binaries are inside your libraries are inside your binary. Whereas if you're doing a shared library, then they're outside, typically on the operating system. That means that multiple applications can use that shared library. Pretty common concept. Within a Docker environment or in a container environment, you have a single process in a container. There is absolutely no reason that you should ever have this model here on the right with a shared library. You should be statically compiling. So we have this thing called Scratch. Scratch is a special keyword. You can use it in your build file. It is a no-op keyword. That means that it does not create another file system layer. Awesome. You end up with only your application as the base image. This means you can't do a Docker exec login. You can't do anything. The only thing that's running is your application. Google agree with me, which is really nice to know, because I'd hate to point out that they were wrong. Killer Cruft. This is what this is about. And I'm going to show you, and I use C because, like me, it is old. So I've got an application. I've actually pre-compiled it. You can see them there. It's a little listener application. It's written in C. First one, dynamically compiled, 20K. Second one, statically compiled. It's about 1.1 meg. Not a big difference, right? The statically compiled one, the binaries are inside. You can check that with, in my dynamic one, that's the libraries that it uses out on the operating system. My static one, it's not a dynamic executable. I've got a Docker file here, and I've pre-prepared it. The first one that I'm going to do, I'm going to use this thing here, which is a Red Hat base image, and I'm going to build that right now. Just bear with me. What do I do right now? Build. Oh yeah, that's just the name. Doesn't matter. Yeah, so that's built. You can see it up here, my dynamic listener. That image is now 193 meg. So it's a C application, it's really old, like me, and like me, it's pretty fat, right? Let's slim this bad boy down to size. So I go back to my Docker file, and I say, and I've pre-prepared this, right? So I'm just going to comment stuff out. I'm just going to say, I'm going to use that special keyword called Scratch, and all I'm going to do is make sure that I use my statically linked binary, which is my 1.1 meg. So I run my thing again. I'll just call that static. And you can see this guy here, 1.1 meg. Thank you very much. That is why you should statically compile. I am really old. if I have to wait for a 193 meg image to push to a remote registry, I could die while that is happening. I am literally that old, right? So the real reasons that you want to kill the Cruft and make sure that you've got these really small, lightweight images. Smaller image size, that's nice. Faster startup speed, does that matter? Maybe it does, maybe it doesn't. Faster image push, Scott doesn't want to die. You also have a reduced attack surface because there's less libraries that are in your base image. And the last one I really like, you get serenity from understanding something a little bit more. I'm Scott van Kalken. Thank you very much.